Hello guys, this is CodeNCode and this is 11th lecture of string algorithm series. In this lecture we are going to specifically study the implementation of insertion and search in the Trie data structure. This is the follow-up lecture from the 10th lecture of the same algorithm string algorithm series. So if you haven't watched that lecture, go ahead and do that first. Okay, so in this lecture primarily we'll be learning the implementation of insertion and search in Trie data structure, and at the end of the video I'll also be providing you a practice problem where you can practice the newly learned Trie data structure. Okay, so this is just a recap of what we did. This is just an example of how insertion in trie works. So this is the root node of the trie data structure, and we always start from the root. Okay, whenever we have to insert or search, whatever you want to do, we always start from the root. We see whether when we are going to insert, we start from the first character till the last. So we see first b exists or not. Doesn't exist, so we'd create a new node for b and we would move on there. We see a exists or not in the as the child of this current node. So of course a does not exist as the child of this node, so we'd create a new node for a and then we move on there. Similarly, we'll see in the child of a there exists d or not. The answer is no, so we'll create a new node and we'll move on there. So bad have been inserted, right? So this is how the insertion goes. Now suppose I wanted to insert bar, so I would again start from root. I would see whether b exists or not. Yes, it does exist, so I don't have to create a new node. I would move on there, and then I would see for a already exists, so no new node created. From this node we see whether r exists as a child of a or not. The answer is no, so we would create a new node as r and we would insert that, and we are finally here, right? So this is how insertion works. So let me show you how this will be implemented in C++. So let me just go ahead and give you an idea what this program does. What it does is it takes an input, integer input, 1, 2 or other number. 1 means insertion in the trie, 2 means search. Okay, how implementation wise it goes I'll show you later. Just let me show you the demo. So 1 means insertion. I want to insert an string. For example, let's say I inserted code, right? So now I want to search. So 2, what I want to search, code. 1 means the string that I've just entered exists. If it returns 0, that means it doesn't exist. So for example, if I had to search code cod only, the result would be 0 because cod does not exist in the trie. What exists is code. Let's insert cod as well, and now let's go ahead and search cod. As you can see, it returns true. So this is how the searching works. Let's just insert one more CodeNCode, and I'll just search CodeNCode. The answer is 1. Okay, so this is how this program is working, and implementation wise how insert and search are working. Let's just go ahead and see. So let's go and start with the structure of the of each node. Now since each I'm going to insert only words with small letter English words, English character. So there are only 26 characters, right? So each node can have pointer to 26 different nodes because of 26 different characters. That is why the node, let me just increase the font size. The node is having two properties. First is end of word, second is node pointers to 26 an array of node pointer. Basically it will be pointing to same kind of data. Basically it will be pointing to different nodes, and size of that is 26 because for now we have 26 different characters. So different 26 different child can a node can have 26 child. That's why we have an array of node pointer of size 26, right? And this is a boolean property which represents whether this is end of word or not. For example, I have inserted bad, right? So bad is actually, this node is actually an end of a word because of bad, right? Ba is not an end of a word, so for this node end of word would be false, right? So we only need these two things. Now get node doesn't do anything special. It just creates a new node and all of the initializes all of the values and then returns it. So as you can see, initializes end of word with false and the 26 character with pointer to 26, these 26 pointer to null. Okay, the initial, it only does the initialization part and returns the node. Okay, now how insertion work? As you have seen, we would start from the root and then character by character, we will see whether that node exists or not. If it doesn't exist, we would create new node and then move on there, right? So here you see in the insertion part, we are reading an input of type string and then calling the insert function with the root node. There will be one main root node and we won't make any changes to it, right? So there is a node, root node, and all of the, since I've already told you, all of whenever we are going to insert or search, we always start from the root, right? So we must have that pointer to ourselves, and this is the most important pointer. So we would keep this to ourselves. So whenever we are going to insert, we would insert starting from root, where wherever we are going to search, we would search starting from root, right? So let's go to insert function first, right? Since root is the most important pointer, it should not get changed in any way, right? And since we need to update every time this we are here pointer, which is basically this temporary pointer, since we are updating it again and again, we should not update the root pointer. That is why I'm creating a copy and I'm not changing the original one, because since this is passed as pointer, whatever changes, if you do any changes to root in this function, that would be reflected back to here, and we should never ever change the value of root. That's why every time wherever you are going to either insert or search, make a copy of root of make a copy of root and work on that. Okay, never update the root. So I'm just creating a copy of root so that I can work on here. This basically represents your we are here pointer, right? What we do for each character, we calculate its index. Basically, if it's a, index is 0 and 1 and so on, right? Because we have 26 different nodes to point. We create the index and we see whether that node exists or not. For example, when we were here, let me just go ahead, we were inserted bar and we were here at the root, we see whether pointer to b exists or not, and that is exactly what we are seeing here. If it is null, that means the node does not exist. In that case, what you would do, this will point, you would create a new node and this would point to that newly created node. This is for that character, right? If it already exists, this won't get executed. Basically, you are not creating a new node. And then what you do, you simply move on to the next node, right? You are here, you see whether the node exists or not. If it doesn't exist, you are creating new node, get node, right? If it already exists, what we are doing, we are simply moving from there to there, and that is exactly what is happening here, right? So we have done, we were here and we see whether b exists or not. Yes, it does exist. We don't do anything. Same for a. From here we see whether pointer to r exists or not. The answer would be null, so we would create new node and make it point to r, right? And then we also move here. This is the part where we are moving down. Okay, temp of root is equals to temp of, because AR of index is actually pointing to that node. For example, when we were here and I have to insert R, so AR of R, you would first of all find out the index. For R, I don't know what is. For A, it is 0. For B, is 1, and so on. For R, it would be something. So AR of that number, say it is 23. I don't know. Say it is 23. So AR of 23 initially was null. So what you done? You've created new node, and now AR of 23 is pointing to that node, which is R itself. So to move from there to there, what you would do? Temp root is equals to AR of 23, right? And we are using the arrow operator because temp root is actually a pointer, right? In C++ we use arrow operator if we are accessing properties of a pointer, right? So this way we are moving down, and finally when we stop processing everything, where is the we are here pointer? At the end of the word, right? At that point you have to set end of word to be true, right? So for this node I would set end of word to be true. So this is how insertion is working. For searching, what you do, simply copy all of this code, paste here, and change one or two things. What? First of all, everything would be same. You would create copy of the root because we don't want the root to be changed. We would process the character. We would process each character. For example, I have this tree, this try, and then I want to search BA. CK, for example. So what I would do, I'll process all of the characters from left to right, and that is exactly what is happening here. Each time I'll create the index and see whether that node exists or not. For example, if I had to search for BAN, I would see whether B exists or not. Yes, it does exist. I search whether A exists or not. Yes, it does exist. Then I would see whether N exists in the child of A or not. The answer is no. That means AR of that index would be null, right? In that case, that word does not exist in the trie, and as soon as that happens, as soon as this condition is met in the search, we will return false, right? For example, I am at root, I want to search directly say dog. Okay, so first character is D. At root I would see whether dog, so D 0 1 2, so 3, AR of 3 exists or not. So answer is no, AR of 3 is actually null. In this case, what is happening, D does not exist in the trie as the first character, right? In that case, what you do, you'd simply return false because dog does not exist in the trie. Otherwise, what would happen? Simply move to that character. For example, if you were to search bad, B exists, yes, move your character there. A exists, yes, move your character there. D exists, yes, move your character there. As soon as you reach last, right, your processing would stop. Your temp root would actually point to that node, the last character of the word that you are searching, and there you have to check whether this is end of word or not. For example, BAC, if you were to search BAC, you VR here pointer would stop here, and at the end this is condition which is checking whether this is end of word or not. The answer is no, BAC is not end of word because we haven't inserted BAC. So when we reach end of that node, we have to check whether it is true or false. So from here we are directly returning end of false. If it is not end of word, of course it would return false, otherwise it would return true, right? So this is how insertion and search works in trie data structure. I'll be providing the code in the description of the video, so you can go ahead and look at that. If you find any doubt or query, you can ask me in the comment section. And when it comes to the practice problem, I'll be providing the link of this problem in the description of the video. This is very easy problem that you can solve using the trie that we have just learned. Okay, so this is word queries. Basically, there are n insertion in the trie, and then after there are q queries. So it would make you insert n words, and after that it would give you q queries. In each time it would give you a string, and you have to tell for how many words this exists as their prefix. For example, cat is the first query, and it exists as prefix for these two words, so the answer is 2, right? To solve this problem, what you have learned today, you would utilize this knowledge as well as what I have actually given the hint to solve this problem in lecture 10. So you can go ahead and watch the lecture 10 again, or if you are able to understand how you'll solve that problem, that's good too. So we should stop here. So yeah, this was all for this lecture. Thank you guys for watching, and till the next video erupts, keep coding. Thank you.